Hello, good afternoon, good morning, good evening, everybody. Welcome to Rancher and SUSE's Kubernetes Masterclass today on Tuesday, May 11th. My name is Connie Lin. I'm your host today. I'm Global Events Manager at SUSE, formerly from the Rancher team. And our speaker today is Matt Maddox, Principal Support Engineer at SUSE. We are also joined by Lucas Ramage, Support Engineer at SUSE as well, who will be helping with today's Q&A. So if you are not familiar with our masterclass series, these are sessions that run about 45 to 75 minutes, followed by Q&A. If you have any questions throughout the class, feel free to pop them into your questions tab at any time. You can see that on your GoToWebinar panel. So, as we go through the content today, pop those in. Lucas will help answer them, and then Matt will cover most of the Q&A towards the end of the session. We also have a Slack network, Rancher users. You can go to slack.rancher.io to join, and we have a dedicated channel there for masterclasses, as well as a bunch of other channels dedicated to specific projects, other events that we host. So make sure to join our Slack channel so you can connect with us and others in the community. Speaking of community, we have a new website that you guys can join and connect with others. You can visit community.suse.com. It's a joint community for both SUSE and Rancher users and experts. We list events there. There's other all kinds of resources up there that you can find. So make sure to register for this new community network today. And with that, I'm going to hand it over to today's speaker today, Matt Maddox, to dive into our topic, disaster recovery with Rancher and Kubernetes.
Awesome. Okay, so today we're going to go over disaster recovery. Real quick, we're going to go over some basic terms just so that we're all on the same page. And then we're just going to dive right into the scenarios. These scenarios are set up as lab examples where you can reproduce most of these in your lab. I encourage you to do that. The worst time to learn how to do a recovery is at 3 o'clock in the morning when you're very tired. And then finally, we're going to end with Q&A. I'm going to try to leave as much time for Q&A at the end. And then finally, as I do in all my master's classes, I post everything in GitHub, all my examples, scripts. Basically, this entire PowerPoint, including the PowerPoint, will be available in GitHub. So if you just want to skip all the way to the end, there's the link. Okay, just some basic terms. Rancher servers, of course, the pod that actually runs the Rancher UI and orchestration engine. The big one that we're going to be dealing with today is RKE, which is Rancher's Kubernetes engine. It's the tool that Rancher uses to build Kubernetes clusters. And then local and upstream clusters, that's basically where Rancher runs. And same thing with downstream is clusters that are managed by Rancher. Okay, so these are the scenarios that we're going to cover today. Hopefully we are able to get through all of them, but we might have to cut some if we start running a little long. All of these scenarios have been experienced by customers, and we've of course been able to resolve all of them, and all of these have scripts for reproducing them. So we're going to go ahead and just dive right into it. So the first and probably the scariest one is an NCD Split brain. The first question I always get is, what is NCD? And NCD is the database for Kubernetes. It's what stores the state of the cluster. It stores all your config maps, your deployments, your secrets. Everything about the cluster goes to NCD. It's the only thing that is not stateless in Kubernetes. Everything else is stateless and can be thrown away and rebuilt at any time. NCD is the only one that we really care about. Hence why when it goes split brain, which is where NCD, of course, is an erasure-coded database, meaning everything always has to have quorum. If quorum is ever lost, meaning let's say you have a 3-node cluster and you lose 2 nodes, the surviving node cannot accept writes at that point because he doesn't have quorum. He doesn't know if he's the one that's segmented and the other 2 are still alive, or vice versa. So it just does the safest thing and puts its hands up and says, I don't know what to do. I'm going to go in read-only mode until you fix me. So of course, we're just going to dive right into this lab. So for NCD Split Brain, I always like that picture. All these labs follow basically the same guideline as far as the setup. I do encourage people to test these. These are very small boxes, 2x4 boxes. You could probably get away with like a 2x2 box. It would just be slower, but I definitely encourage you to test them out. Very minimal specs. And of course, I provide the cluster YAMLs. These are the definitions of the cluster. And then, of course, we have the build scripts. This script mainly is there. It sets up the environment for you. Once you run this, the cluster should be in a healthy state and ready to go. And of course, you can validate it through here. I've already done all these steps because these can take like 10-15 minutes to run just to save time. The real juicy part is when we get into the break script. So if I come in here and we take a look at the break script. So in this case, I'm going to be very, very bad. I'm going to go into NCD and I'm going to tell one of the nodes, you are now a brand new cluster. Go ahead and initialize yourself as a brand new cluster. At that point, I'm basically turning off a lot of the safeguards that are built into NCD. By default, when NCD comes up, it assumes that the rest of the cluster is also up as well, and will try to reach out to its nodes and get its state and get back into sync with the rest of the cluster. In this case, I'm telling it, no, just ignore all that. Just come up as one. It's very, very bad. You would never actually do this, but it happens. So of course, in this state, I'm just going to go ahead and run that. And it's just SSHing into the first node in the cluster. And also while this is running, so I have these as all separate labs with separate VMs. You don't have to do that. You can reuse the same VMs over and over. And that's fine because I already ran it. So in this case, if I go and run my verify script again, you'll notice that the first node in the cluster is throwing a lot of errors. And that's a simple fact that he thinks he is now a brand new cluster with 2 nodes that are waiting to join him, and those 2 nodes are not responding. Yep. So you can see here, it's complaining because NCD is sitting there crashing over and over again. Then it's going to go into node 2, and node 2 should be up and running. One of the things that trips up a lot of newcomers, so this is node 1. You see how he's reporting has started? Everybody always thinks that, oh, that means that he's up and healthy. No. That simply just means that that member has been seen and he has been sunk at least once. The key one is this endpoint health. This runs the actual health check against that node and validates that the NCD is up and running on that node. So as you can see here, I intentionally broke one of the NCD members with the other 2 still running. I could, of course, repeat this on node 2. One of the things is NCD, and especially newer versions of NCD, we're on 3.4 right now. It's actually very hard to do split brains anymore. It was a lot easier back in the day. If you power down all 3 nodes at one time and powered them back up, they would immediately go into split brain. The new erasure coding and the new checkpoint system has solved a lot of that. So it's just something that doesn't happen anymore. But this is also one of the reasons that we always recommend odd numbered nodes, because you'll never get into a case where, if let's say I have a 4th node down here, I could have this guy and this guy up and running as a cluster by themselves, and this guy running as a cluster by themselves, but they're all not agreeing with each other, and then that can get really bad at that point. Where's my slides here? So one of the things you'll notice is if we come in here and we take a look, it's saying cluster ID mismatching, which when I initialized the brand new cluster, it created a new cluster ID for itself. Every cluster has a unique identifier. I believe it's like based off the initial host name or something like that. So it's saying, hey, this is my ID, but when I talk to my peers, they're reporting a totally different ID number, and it doesn't agree with me. So I'm just gonna throw my hands up, and in this case, NCD is just crashing because it knows that something is wrong. And of course, we can run this endpoint command. Again, this is just some bash stuff. Again, this is the super misleading part, and I wish that they would change this. This is our broken node, but there's nothing about this command that tells you it's broken. It's the endpoint health check that's going to tell us that it's broken. And in this case, I have seen during the split brains where it will misreport this. So don't always trust it. I would more focus on the Docker logs. Again, this is for older NCD versions, newer ones are much better. More just focus on the Docker logs. Of course, because our key, everything's a container, we don't actually install anything on the box itself. Everything is just Docker logs and Docker PS to see what the status of them are. One of our primary tools with RKE clusters is RKE up. RKE up basically will try to reconcile the cluster. And in this case, let's go ahead and we'll just run this in the background. RKE up is going to dial into those boxes, and it's going to check the state of everything. So in this case, it should see that one of those containers is broken, and say, hey, this container, because I've changed the settings, is different. I need to redeploy that and resync it to the cluster and rejoin it. And then 99% of the time, happy, healthy, and it works at that point. So this is primarily, this will just solve all of your problems. If this doesn't solve your problem, such as one case we had where these two nodes were lost and there was only one surviving member. And it was production system, hey, we just got to get it up and running while the hardware team goes and provisions us 2 new servers, but that's going to take a couple hours. So that's when you go into this, what's called NCD tools. This is written by one of our Rancher colleagues. This tool actually goes in and basically does surgery to NCD and tells it to go ahead and force a new cluster to come up as a node of 1, ignore all the other members, just come up, and then it walks you through the process of manually rejoining them to the cluster. Again, we do this preferably if you're a Rancher support customer, please do it with us on the phone. But if you're just a community member, you just follow the steps here. I would recommend setting up SSH keys because it just makes your life a lot easier. Okay, and then the key one is preventative tasks. We never want to get into a scenario where NCD is not healthy, because if NCD is down, everything else is down. Keep APIs down, which means schedulers down, which means controllers down, which means just the whole cluster is effectively down at that point. That being said, we want to leverage tools like VMware's anti-infinity rules to make sure that a single, let's say a single blade in a chassis, we don't want all 3 of our NCD nodes sitting on that blade, or even more likely 2 of those nodes sitting on the same blade. So we want to leverage our anti-infinity rules. Just talk to your VMware team and say, hey, keep these 3 these VMs on different boxes, please and thank you. We of course always encourage more and more. Hey, if you have multiple chassis, multiple racks, all that kind of stuff, the more redundancy that you can build into it, the better. Of course, that leads into Amazon. Leveraging Amazon's, A1, all the different subregions. One of the things that we recommend against is running across regions. So like having a node in US 1 and US 2, that's not good. Your latency is just going to be too crazy high, and your cluster is going to be constantly timing out and going down. Subregion is totally okay. Metro clusters are totally okay. The rule of thumb is 10 milliseconds. Anything above that, you're going to start running into problems. And then the other one, of course, is patching. We almost always see NCDs going split brain, either due to a power outage or an aggressive patching schedule, such as somebody patched all 3 boxes at the same time and took them all down. This is a script that I wrote. You can, of course, modify this to your heart's content. It basically just walks through kubectl get nodes and SSHs in, it drains and cordons them and patches them in a very controlled fashion. I see a lot of my customers will go and use Ansible playbooks and Chef and Puppet and all those cool other automation tools to basically prep the node and give your patching the intelligence to say, hey, don't take down all these nodes at the same time. And also the key thing is make sure the nodes are back and healthy and in the ready state before proceeding to the next node. NCD and control plane are really the two that we're most concerned about. The worker plane, that's really on your application's availability. If you take down half your workers at the same time, hey, as long as your apps can ride through that, that's okay with us. NCD and control plane are the two that we want to focus on most. And then the other one, and this is actually a really good doc, is the NCD failure. It more just talks about in more detail of what each of the different failure modes mean. Network partitioning. That is another thing that I usually do recommend, is putting the nodes in the same subnet if possible. It stops latency, stops firewall issues, and router issues of partitioning your cluster and causing issues around that. Again, where applicable. And now we're going to go into rebuilding from NCD backup. So one of the things that I tell customers is because NCD, I got a typo there, NCD stores everything about the cluster, from secrets, config maps, all that jazz. As long as I have a backup of NCD, I can rebuild your cluster from scratch. Meteorite hits your data center, so you give me that S3 backup of NCD, and I can rebuild it. So if I come in here, and what did I call it? It was rebuild from scratch. So of course I ran the build and break and all that jazz. Let's go into that real quick. From scratch. So this lab's a little special, and he's got 6 VMs. It's for the simple fact that we're going to have 3 VMs of our current nodes, and then we're going to simulate that your colleague logged in and accidentally deleted all 3 of your nodes because he messed up on the ticket or something like that. So we're going to assume that the nodes are gone. We don't have backups of those VMs. They're non-recoverable. The only thing that we have is the cluster.yaml and an NCD backup, which in this case is stored in S3. One of the things is this doesn't have to be Amazon S3. Any S3 provider works as long as it's a fully qualified S3 provider. Wink, wink, hint, hint. Most enterprise storage arrays support S3. So it's not always super hard to get S3, even if you're in air-gapped environments. So in this case, again, we're going to kind of skip to this breaking step. And we'll go in here for the breaking script. As you can see here, I'm going in, and let me actually share the cluster.yaml first. So in this case, I have my first 3 nodes, and then I have the quote unquote new nodes are currently commented out. So these just don't apply right now. And in my breaking script, I'm going through and I'm powering off all 3 of the Docker stopping equivalent of just powering them off. So let me go in there. Yep, and it's already broke right now. That's cool. Okay, so if I come in here, let's make sure I have my kubeconfig file set correctly. And my cluster should already be down at this point. And we get a couple seconds. This will time out because effectively right now my cluster is dead in the water. Control C that. So all we're gonna do is In this case, you'd be reaching out to your VMware team, your infrastructure team, whatever, and saying, you know, hey, I need 3 new VMs. And of course, in this scenario, I have all nodes running the same role. You'll want to match the roles as much as possible, such as, let's say you had 3 etcd, 2 controller, and 5 worker. You'd want that same configuration on the new VMs. I believe you can actually do it the other way. And let me just make sure. Yeah. One second. I think I actually want. I have my S3 credentials in here. So one second. And let's go ahead and set it here. And let's just make sure that's the right one. Yeah, okay, sorry. I have my S3 credentials in here. So let me fix that real quick. You can technically do this with local backups. The key thing is, and it's one of the reasons I highly recommend against it, is what do you do when somebody's deleted all 3 of your VMs? They also just deleted your backups at that point. Now, of course, you can get around that. Just make sure. Okay, cool. That's it. Can of course get around that by simply, you know, rsyncing them off somewhere else. Of course, the directory is that. So I have some customers that just they'll rsync that to an NFS share, and then you're just responsible for putting them back into that scenario. Now, of course, I've done the hard work for you of this script. It's kind of long, but the key thing that we're doing here is the etcd restore. So RKE will basically, it's going to build a new cluster, but it's going to use the data that we have from our backup as a seed. So it's going to load that data in first and then build a cluster on top of that. And then this is just some jazz because we reset tokens. So certain service accounts need to be reset as part of the process. So we'll go in here, and what was our snapshot name? That is another thing. So I'm cheating a little bit, and I know the snapshot name ahead of time. You, of course, in a disaster scenario wouldn't know this. So you might have to go into the S3 bucket and pick the snapshot name from the last known good state. The thing that trips up a lot of people is this is also a .zip file. Just make sure you don't have the .zip in it. What is it? Dash restore. Yeah. All right. So what this is going to do is you notice now it's calling into 44, 45, and 46. So it's going in there now. I'm sanitizing the new nodes because again, this is a lab environment, so they've been used before. You wouldn't have to do that step. Yeah, so now it's just going. It restarts Docker, so now it's checking and making sure Docker's actually started. But then this is the key thing that you'll see here is it's actually calling in to S3, and it's going to download that backup to each node. You see, of course, this is a local S3 bucket. Cool. Is that broken right now? Yeah, this might be broken because I know my S3 server was having issues this morning. Yeah, so now it's, okay, so that's not gonna work. So let's just assume that would work. That's a lab issue. It's for the simple fact that I'm hosting my own S3. Again, we're gonna assume that your S3 is on some enterprise solution that's highly available and all that jazz. They deleted that too. There's not much we can do at that point, except for redeploy. Of course, Rancher has some great documentation on going through and restoring. One of the key things that I recommend people do is your cluster.yaml preferably should be in a Git repository somewhere or some other code controlling software. There is passwords that can be stored in there. So please take that with a grain of salt. You might need to sanitize it. You might need to encrypt it, something to that effect. This is also the same process for Rancher managed clusters that are built inside Rancher. It's the same exact process. RKE is really inside Rancher. So it's the exact same thing when you would go into the UI and from the drop-down box hit restore. And then of course the other thing is no backup is worth anything unless it's a reoccurring backup. Now backups are of course turned on by default nowadays. I believe we changed that a couple versions ago. I do recommend evaluating the schedule, making sure that it makes sense for your environment. Do you want to take hourly backups? They're usually super lightweight. These are only usually, a couple hundred megabytes, if that, especially after compression. So I always tell customers, nobody ever got fired for having too many backups. So take that however you want to take that. I'm super aggressive with my backups because I would much rather have more options than less. But of course, take that as you will. Okay, so let's go into the next one. Ooh. So the next most common issue that we have is power outages. So let's assume that you have a data center and it's lost power. Somebody tripped the UPS and everything went down. Again, this kind of goes back to the NCD Split brain. This used to be a lot bigger problem. It's not really a problem anymore, especially with newer versions. But the key thing is, and it's usually like storage, it's when somebody yanks out the storage from underneath of us. So NCD, hold on one second. NCD uses a write-ahead log. So any writes that NCD takes, which are updates, deletes, creates, all that jazz, those are sent to memory, but they're also written down to disk. And before until it makes it down to disk, it's not acknowledged. It's one of the reasons NCD is super sensitive to disk latency, because any latency immediately gets seen upstream from there. And of course, NCD does use the basically file sync, which in this case tells the Linux kernel, hey, don't cache this write. Go ahead and send it to the raw underlying storage device. And usually VMware respects that as well. I have seen in cases where some people will turn off asynchronous writes for performance reasons. Again, NCD assumes that everything is going to make it to persistent storage. So generally speaking, when you have problems, it's because somebody's turned that off somewhere. And NCD wrote something down to disk and it didn't actually make it to disk. This is actually really difficult to reproduce in the lab because NCD is so resilient, and it's something that we actually don't see a lot of anymore. And again, the same scenario of going through, I've already ran all this. And I'm actually going to skip the break part because I wasn't able to consistently in the lab. The only way I was able to consistently do it was by shutting off my NAS in the middle of everything and taking everything down. And I don't want to do that right now. But the big thing here is, again, test this ahead of time. But if you have a planned outage, it's a perfect time. Rancher has docs for how to shut down your cluster in a graceful manner. We of course ran through this multiple times with customers, how to power everything off in the most resilient way possible. But again, the key steps are to do the exact same thing that RKE does. Bring NCD up, make sure it's all cool and healthy. Bring up your control plane, make sure that's cool and healthy. Then bring up your worker nodes, make sure those are cool and healthy. I have seen customers that just go into vCenter, select all VMs, hit power on, wait 5 minutes, and everything just comes up. I've seen customers do that at the same time, and everything's all screwy. If it's screwy, then we go back to the NCD split brain, and we start going through the restore procedures. We don't usually see any kind of issues when bringing up control plane and worker nodes. For the fact they're stateless, as soon as NCD is up, they usually start coming up on their own. And of course, the Rancher UI. The Rancher UI for a cluster showing active is usually like the last thing that happens after the cluster starts up. So what I usually tell people is just be a little bit patient. It might take a few minutes for everything to come up. And you also might see the UI get slow for a period of time as just branchers getting flooded with requests as everything starts up. This is a great thing. One of the things I recommend customers do is if you have a DR strategy where you're like shipping the VMs at like at a storage level or something to that effect, this is a great time to practice this, because you're going to be taking a crash consistent backup and you're shipping everything up and you got to start it up. So you know, investing that time to have this procedure either documented or scripted out is a great thing to do, and it will save yourself in the long run. And again, I really recommend following this doc. Is it Dave wrote this doc? Yeah, Dave Nolan. And again, this doc actually came out of a customer that had this, and they did it fairly regularly of shutting down their environment for power work and then bringing it back up. We actually ran through this like 3 times with them. And each time it was successful. Okay, the next one is OPA Gatekeeper. So this is becoming a problem. For those that don't know, what is OPA Gatekeeper? OPA Gatekeeper is the long-term strategy to replace PSPs. For those that know what PSPs are basically security policies that you put on your pods to say, you know, hey, this pod's allowed to do this pod's not allowed to do this. OPA Gatekeeper takes that idea and expands upon it of, I can set really cool rules like don't allow pulling from Docker Hub, only allow pulling from my hub. Make sure that you have these labels on your projects, and make sure that, you know, all these other parameters. And it's a very extensive, and I really think it is going to kind of shape how policies are driven in clusters. One of the key things is how OPA Gatekeeper works under the covers. Let's go in here. So I'm going too deep in this, but basically every request that comes into Kube API, there's these mutating and validating webhooks that get put in place. So let's say a pod, you know, the scheduler says, hey, I need to create a pod. It passes it through. One of the things is it gets passed down to these validating webhooks, which basically pass the request over to OPA, which is down here. And OPA looks at it and says, yep, that's cool, or nope, that's not cool, and then simply responds back basically a true or a false response to it. The issue then becomes is what happens if this is down? The old way was, hey, if OPA is down, I don't want to let bad pods into my cluster, so I need to fail closed, which means fail any request making it through to that webhook, just stop. So my pods don't get rescheduled, nothing happens in my cluster until OPA is brought up. Well, what do you do if you need to bring up OPA? You know, you get on into a chicken and egg problem. OPA has kind of addressed that at this point. Again, this just restates that. So if I come in here and I look at my Kube scheduler is responsible for once a pod has been requested, it goes and finds nodes to assign that pod and basically builds that pod. And as you can see here, in this case, I have powered down Gatekeeper. So of course, it's going to fail and say, hey, connection refused. And the crazy thing is from kubectl, you really won't see that there's an error in the environment unless you look really closely. You can see here, I've told it to give me 4 pods. It only has 3. I don't see a 4th pod here because Kubescheduler has not even created the pod yet. It just says it's trying to, but it's getting blocked. And of course, this is a useful command. So one of the things is Kubescheduler and Kube Controller Manager. They have a leader election process. There's one control plane node for each service that becomes the leader, which does the work. The other ones are really just sitting there in standby. So one of the things is you go in there and you simply just look at the logs, and it usually becomes very clear and obvious when you see OPA Gatekeeper, and usually you'll see this message being flooded because it's going to sit there and keep retrying over and over and over again. Now, of course, it's actually really easy to fix this issue. We're simply just going to set the failure policy to ignore. What that means is, when in doubt, if OPA doesn't respond or any validating webhook doesn't respond, assume that you would have gotten a good response and just go ahead and proceed. I have seen in older versions where even after changing this, Kube API just doesn't respect the change right away. And we ended up just having to delete the webhook of just going in there, kubectl delete. But a lot of times what we do is we just, kubectl YAML output that, save it somewhere. Of course, there's the doc that basically explains what we're doing here. And they call it failing closed. With the latest version of OPA Gatekeeper, it defaults to failing open. But you do need to talk with your security team if that's okay with them, because basically you're turning off the security rules. So if somebody got in and was being malicious, one of the things they could do is to attack your gatekeeper, knock it offline, and now they disabled your security and start running wild in your cluster. So you do have to kind of weigh the pros and the cons there of availability versus security. And of course, they're super helpful with their emergency recovery procedure. Just delete it and then reapply it after the fact. Let's not talk about that. Okay, and then what's the next one? So I see this a lot in big environments. I call it the app stomping all over my cluster. How a single app can take down my cluster. And go into a little bit of story time. I have a customer of mine. They have a 100 node production cluster. And they had an app team that migrated an app from their mainframe over to Kubernetes. And that single app took down a 100 node cluster. And it wasn't because they deployed 100 pods, they deployed 5. In that case, what ended up happening is Kubernetes has the concept of CPU and memory limits, where you can basically put a minimum and a maximum for CPU and memory on a pod that says, hey, you only get this amount, and we're going to guarantee you this amount of memory and CPU. If you don't specify that, OPA Gatekeeper can enforce that, by the way. If you don't specify, it's unlimited. And in this case, they had kind of smaller size nodes, and this app just basically ran away with the resources. The app, within a few seconds of starting up, would just consume all the CPU and consume all the memory on the boxes and knock the box over. Okay, it's a bad day for that node, but it should be no problem. The issue they ran into was it not only knocked the box over, it didn't crash the box. So when the node locked up, it didn't restart. So that node would go unavailable. After 5 minutes, Kubescheduler goes, okay, that node must be dead. I need to reschedule those pods. And it went happy along rescheduling that bad misbehaving pod on 5 brand new nodes, and rinsed and repeat for 5 minutes. And every 5 minutes, it would sit there and knock nodes offline. Ubuntu tends to handle this a little better. Ubuntu tends to just crash. This was a RHEL environment. You could leave those arguments on the side, but just be aware that it's super, super important that you have, what's this one? Yeah. Again, this one's kind of hard to demo in a lab environment just simply because they're so small, and Ubuntu tends to self-recover. As I say here, generally speaking, if those nodes had come back and reacted properly, such as just crashing and rebooting, they actually wouldn't have had an outage. They would have just had basically 5 nodes and the cluster just persistently crashing at some point. And we've actually seen this too, where it'll sit there and basically bounce between nodes, where it'll crash these nodes and then go to another set of nodes. And by the time it crashes those ones, the first ones are back up, and it just bounces back and forth between those two. In this case, in my break script, let's go, yeah, I do caution running this in any kind of a shared production environment, because this break script basically deploys this stress test tool. This stress test tool is designed to knock a node offline. It is designed to chew up as much resources on the node as possible. It basically sits there and just keeps spawning the Linux stress command and sits there and just tries to eat it all up, both in CPU and memory. So, and of course, one of the things is kubectl top. So it's like top, but for pods. There's also a top nodes as well. And one of the things you'll be able to see if I come in here and take a look at that, and hopefully I haven't taken the cluster offline. Yeah. You can of course use some grep and awk coolness, but you could see how much CPU and memory. This is millicores, so thousands of a core. So this is 1.2 cores. And then of course this is memory. So one of the things that you'll see, especially in really large environments, where you can go through and do some sorts and greps and awks, you could start narrowing it down and seeing, who's misbehaving in my cluster and chewing up all my resources. The other thing that can sometimes happen is, I didn't happen in here. I do here. Docker stats. So one of the things that you could do is if you can SSH into a node in question. So let's say you have a node that is showing, it's swapping or something like that. You can go in and run Docker stats. Let me go ahead and run that real quick. Let's go to the first node. And go ahead and make this text bigger. As you see here, it's running a continuous loop, so you can see how much memory it's using. Kind of ignore the limit column because this is a 4 gig box, so basically everything's set to unlimited, so its limit is 4 gigs. But we actually use this a lot when trying to figure out who's a misbehaving container that's chewing up resources. I will note that if a box is basically on the verge of falling over already, I have seen a Docker stats cause the box to finally fall over. At that point, you're already dead in the water, so there's not much we can really do. One of the things that I've seen some customers automate is scaling of deployments. So if you're mixing production and non-production, such as having load testing is a perfect example of automating the scale down of your load test. So I had another customer that they did load testing in their non-prod environment, which housed like dev, QA, test, all the other letters of the alphabet. And they would do these big perf tests. Well, they ended up having like a rack outage where they lost basically like half their worker nodes. Luckily, they had scripted out the ability to basically go and use labels to find all of the performance testing workloads and scale them all to 0. So that basically, hey, give us that resources back. So investing in that kind of stuff really could kind of save the day. But the key one is limits. You should be working with your performance and capacity planning team to set realistic limits. Now, you don't want to set the request is basically guarantees. So in this case, if I deployed a workload, I'm guaranteeing it 250 megabytes that I'm carving out and saying, yep, this is for you. Not actually carving it out, but I'm reserving that capacity for you. And then I'm saying, hey, at 500 megabytes, I'm gonna let you stay there for, I believe it's 10 seconds in the current version. If you stay above 500 megabytes of usage for 5 seconds, it's either 5 or 10. Sorry, I'm gonna kill you. I'm just gonna kill mine, kill your process, and you're gonna out of memory get killed, and your pod's gonna go down. So do set these as realistic numbers. Don't go crazy and don't set them like 2 terabytes in a box that's only got 4 gigs of RAM. Do set them realistically. And same thing with your requests. Don't go crazy setting your requests super high. Such as, let's say I only really need 100 megabytes, but I'm basically chewing up 150 megabytes that another pod can't use. So do work with your performance capacity planning team to give realistic numbers. And this is part of also tuning a cluster is looking at those and evaluating them over time using things like Prometheus and Grafana. And then of course, OPA Gatekeeper, and it's one of the reasons I love OPA Gatekeeper. OPA Gatekeeper has the ability to enforce those. So it will basically not let containers be deployed in your environment that don't have those. So in that case, an app team, they deployed that. If this was in place, the app team would have deployed it, and the deployment would have been blocked from the get-go because it didn't have CPU and memory limits. So the app team would have never even gotten the door at that point. Now in this case, it just makes sure that they're set. So they could set this to 99999 and it would let it through, but it has to be set. And then I believe, yes, these are some other additional examples, mostly focusing on OPA Gatekeeper, because that's kind of really their big selling point right now. Okay, and the next one, kubectl. So little backstory, Kubernetes does everything as over SSL. All of the internal services, both Kube API, its ED, scheduler, controller, everything is done over SSL. And to make that work, of course, these are valid certificates. They have to be signed by a root authority to make it easier for customers. So you don't actually have to go out and have your root authority sign all these certificates and spend all day signing certificates. One of the things that Arcade does is it creates this root authority called kubectl, where he's the root certificate, everything trusts him, everything is signed by him. Well, what could happen is what happens when that changes. It's the same thing as a root authority changes in a regular SSL certificate. Now suddenly nothing trusts it because, hey, it's signed by something I don't know who that authority is. It's some other, CA out there. Mind you, newer versions of RKE, this is 10 years, so you really shouldn't have this problem. Older versions, we did have problems with this. But usually, when we see this, it usually exposes itself as suddenly internal services like Prometheus or Ingress Nginx suddenly stop working. As you can see here from the Nginx logs, it's trying to call into, this is the internal address for the Kubernetes API endpoint. It's saying, hey, I'm trying to call in, and the certificate that they gave me, I don't know this certificate. It's not valid. I might be getting a man in the middle attacked. I don't know what to do. I'm going to throw my hands up and stop. Again, it's the safest thing to do. Just stop and don't do anything. And again, Kubernetes is built around the idea that it's better just to throw your hands up and stop than to move forward in an unsafe and unsecure manner. And of course, one of the things you can do is turn off TLS verification. TLS is the equivalent of doing the -K in curl. It says, hey, go ahead and still check the certificates, but even if it returns bad, just go ahead and continue on. It's very, very dangerous, and I would only use that for troubleshooting. But you can go ahead and proceed at that point. A lot of services like Nginx, there just simply isn't a flag to set that. It's going to say, no, you have to have valid certificates or I will not work. Plain and simple, end of story. One of the things that RKE does is we store our certificates on the host. They're stored in Etsy Kubernetes SSL. So if we come in here, go and jump into this box, I'm going to close that. And as you see here, so this is, again, this node has all roles, but as you can see here, I have my kubectl, I have my API server, I have my NCD, I have my control plane. The other one to remember is This is basically the certificate that all of the tokens inside Kubernetes. So when a pod requests and says, hey, I want to talk to the Kube API server, here's my service account, it's defined in my deployment. It goes, cool, here's your token. That token is signed with this certificate. This certificate, of course, is signed by KubeCA. If this changes, suddenly this no longer is trusted, so now that token is no longer trusted. And I think I have this lab set up, don't I? And KubeCA. Yeah, I think I set this up last night. Let's check. Yeah, so it's not working right now because I had to rebuild my lab at the last minute. So one of the nice things, RKA has a system built in place where you can basically tell RKA, hey, I want to rotate my certificates. By default, it doesn't rotate your CA because when you do that, it basically invalidates all your tokens, which is this step right here. This is also great if your tokens have ever been compromised, such as, let's say you accidentally shared a private key or security doesn't like it or whatever. Especially if you've like signed your own certificates, that's another option too. Is you could have RKE give you a signing request, and then your internal certificate authority can sign those requests, so they'll be trusted throughout your organization. But basically, you run this, and what it does is it says, okay, I'm going to regenerate all those certificates from scratch. I'm going to go in here. I'm going to create a new KubeCA. I'm going to create a new Kube API cert and walk through basically everything. It's going to cycle everything because now those have changed. And then one extra caveat, because those tokens are based on the service account cert, which now has been changed, we do need to basically go through the entire cluster, get those secrets, which are these service account tokens, and we basically just need to delete them all. Now, of course, Kubernetes is really nice to us, and we'll say, okay, my token secret has been deleted. I just need to regenerate it. It'll just simply, the controller kicks in and will simply just create a brand new one. So what you'll see is you run this, and by the time it's done, they'll as soon as they're called, they'll get recreated. The other thing is we generally actually usually see this when people run older versions of RKE and they don't have their cluster RKE state file, which houses the Kubernetes secrets, Kubernetes certs. Newer versions, if we don't find that file, we'll go out the cluster and try to get it. So again, it's kind of been fixed at this point. But when in doubt, if everything's totally sideways, just do an NCD restore. Again, the restore command's there. One of the nice things that we do is in the NCD restore, we also back up the certificates. So all of those certificates are backed up there, and the RKE NCD restore will go ahead and take care of that for you, of going and grabbing those certificates out of the backup and then redeploying it. It really isn't a preventative task. This article is just really good about talking about what are certificates and how do they work in Kubernetes. One of the key things to remember, this has absolutely nothing to do with your SSL certs for like Nginx ingress. Totally separate. These certs are for the Kubernetes components, not for your applications. So I just sometimes those wires get crossed in conversations. And then let's go next one. This is also another one that I see a lot. Let's say we have a customer that will, maybe they're working on a dev script and they log in and go, okay, I'm just going to delete the namespace and I'm going to recreate it. And oh no, I was actually logged into production and I just deleted my production namespace. Oh crud, oh crud, oh crud. You're like, okay, I deleted it. I'll just recreate it. kubectl create namespace, and you'll get an error back saying your namespace already exists. It's currently terminating. and you log in, well, like, hey, everything's cleaned up. I log in and I see that my namespace, it's sitting in this terminating state. I can't do anything. I can't finish deleting it. I can't create it new. What do I do? The reason that you're running into this issue is finalizers. So Kubernetes has this concept, again, back to our safety conversation, of basically when a controller, and I'm going to kind of pick on volumes, let's pick on Longhorn. When Longhorn deploys a volume, it will add a finalizer to whatever is the object that owns it. In this case, let's say a pod. It will say, hey, I'm going to add a finalizer. Call me when you are going into the terminating state. And basically at that point, Longhorn, when it sees that that resource is now terminating, it goes, okay, I need to do my job to clean up my stuff. Okay, everything's cleaned up. I'm going to remove my finalizer. And that goes all the way up from the pod to the deployment to the namespace. And one of the things that we see a lot is what are called stuck finalizers, where there's some other finalizer in there that is either the controller that manages that finalizer is broken, such as somebody deleted the Prometheus namespace. Well, Prometheus deploys finalizers. Well, now suddenly there is no Prometheus to clean up the finalizer on the namespace where Prometheus was deployed, and you're getting a chicken and an egg. As you can see here, and of course, I added some fake ones in here. The other thing is like CRD objects could be left behind there too, and the CRD objects are not getting cleaned up. But one of the key things that I do a lot is the get all, which says give me all resources in a namespace, and just see, hey, do I have a pod stuck? Do I have a deployment that's stuck for some reason? Because again, finalizers, they're a safety mechanism. We just don't want to delete them unless we're 100% sure that we know it's safe and that the cluster is just in a weird state. And of course, this is also another command that cycles through CRDs, which are custom objects in Kubernetes, and tries to look and see, hey, do I have some custom object out there that's not showing up in the get all? Because again, this only gets Kubernetes native objects. This one will get custom Kubernetes objects. Again, kind of picking on Prometheus. Prometheus loves to leave stuff behind. So let's say that you've gone through all those steps, and I think I have that here. Let's see, is that lab up right now? And namespace text terminating. I think it's currently up. No, it's not up right now. All right, let's go back here. So basically what we'll do is, again, assuming if you're a Rancher support customer, definitely reach out to us first to double check. But assuming that, hey, this finalizer is stuck for a reason, Prometheus is not available, Longhorn's not available, something is not available, you can basically run this patch command to null out that finalizer and say, go ahead and just remove it. Older versions of kubectl didn't allow this. There were safety mechanisms in place to say, no, you're not allowed to do this, plain and simple. And there were some hacks that you had to do. And of course, there's some documentation. Again, I highly caution against using it unless you're absolutely sure you know what you're doing. Because what can happen is, let's say there was a volume in there. There was a pod still in that namespace. Well, now you've just deleted that namespace. Kubernetes doesn't have that parent relationship, so there's nowhere to find that anymore. So you can basically have orphan objects in your environment that you have no idea that they're even existing. So it's very important that you really are 100% sure. Again, if you're a Rancher customer, please reach out. And then again, this is another really great documentation on how finalizers work, and it's really good read. But this kind of just dives into what it's actually doing under the covers. It is normal, especially in bigger namespaces. So let's say that you have a namespace with 100 pods in it. It could take 5-10 minutes for everything to clean up. That's normal. So I usually tell people, hey, go grab a coffee, maybe go get some cookies and some donuts and come back, let Kubernetes do its thing. Again, it's a safety mechanism, so we want to give it an opportunity to actually do the proper thing. Okay, and now we're getting into Q&A. Great, finished on time. Okay, so Lucas, do we have any questions?
Hey, yeah, we have quite a few.
Yeah, that's what I figured. Hence, I've given a lot of time to Q&A.
Yeah, no, that's perfect. All right, the first one is going to be a question about RKE2 backup and restore process. Can you speak to that?
I'm not a good person to ask that. I'm not very familiar with RK2. That's not really my area of expertise. If you wouldn't mind, for that question, if you could post that in the master's class channel, I'd be more than happy to reach out to one of our RK2 guys to have them answer your question. I believe it's the same basic process. RK2 is really RK for K3S. It's the same methodology, but it is handled a little differently in the fact that you don't have an external binary managing a cluster. It's self-managed. I'm just not super familiar with it and don't want to give you bad information on that one.
Okay, cool. The next one, a little bit easier. How do we rebuild a Rancher managed cluster using a snapshot made by Rancher?
So it depends on your definition of rebuild. If somebody went in, and let me actually bring up one of my lab environments. And let's say, Matt was super tired and accidentally logged in here and selected this cluster and deleted this cluster. So to rebuild this cluster, mind you, the VMs and everything are still going to be there unless it's a Rancher managed cluster where Rancher manages the nodes as well. The nodes will actually get cleaned up, and the Rancher is going to do exactly what you told it to do and clean everything up. In that case, your only option is to grab the NCD backup, build a new cluster, and then you're going to have to use, I've got it here in our, you're basically going to have to do some surgery to manually, so you'll build a brand new cluster, new VMs, and all that jazz. And then what you're going to do is you're going to come in here and use NCD tools. And one of the things that you can do here is, where's his restore? Yeah. So the single node restore, you'll take the raw backup from your S3 and you're basically going to inject it into that cluster. Now, of course, Rancher's going to hoot and holler at you. It's going to go, well, hey, this doesn't make sense. The nodes don't match up. After updating the cluster and running through this process, it should rectify itself. The only issue you're going to run into is projects. Project ID numbers are unique to a cluster. So all the project ID numbers are no longer going to be valid anymore. Everything's just going to be under one project called all project. So you will have to move it back into the different positions. The better approach is, if it just happened, restore Rancher, go to your local cluster and roll the local cluster back so the cluster's back there. And then at that point, the cluster should show up, and then you can simply just do a regular restore. Hence, my local cluster, generally, I crank those backups up. I usually do them every hour to half hour, just so I can easily restore that.
Okay, cool. Let's move on here. So we have another question about backups.
Okay.
If you have a VM level backup, can you restore the VM backups without breaking XCD?
So, and I've done this before. If, let's say, I have a 3-node cluster, and I have node 1, 2, and 3, and they're all etcd nodes, and I lose node 3, bad patch, and the whole box is gone. if I take that node 3 and I go into Commvault or whatever backup tool you're using, Veeam, and I roll that VM back to, a couple hours ago. Well, suddenly now I have a member of my cluster that's now has an hour-old data that thinks he's in sync with the rest of the cluster and is really not. In that case, I would simply throw out node 3. I would go into my cluster.yaml or my Ranch UI. I would remove that node and I would throw him away and then bring in either a fresh VM or bring that VM back and then sanitize it using our extended cleanup script and then bring it back in as a fresh node. Now, if let's say I was recovering from a disaster, somebody deleted all my stuff, I don't have S3 backups, you can of course restore. If you're lucky and you have consistency groups, just simply restore all 3 boxes and you should be ready to rock and roll. If you don't, pick the newest one and run through this exact same NCD tools and basically walk through this process of picking a surviving member and saying, okay, you are now the new master, and bring up the rest of the cluster off of him. Same thing with worker nodes. Worker nodes or control plane nodes, you really shouldn't be restoring them from snapshots unless you're in a disaster scenario. And even then, you're usually much better off and have a much better chance of success of just rebuilding from scratch.
Okay. Here's a real easy question. Can you store the backups in Azure Blob Storage?
So Azure Blob, it wants to be S3, but it's not S3. The RK just uses a standard Go binary S3 library thing. And because Azure Blob doesn't speak real S3, currently that's not available today. There is, I forget, it's like an S3 gateway that Azure can provide you that basically converts Azure Blob into S3. I've seen mixed success with that. What I usually tell people is, hey, talk with your storage guys, see if you can get an S3 bucket. If worst comes to worst, just rsync that directory. Set up some rsync scripts and rsync it to an NFS share or a CIF share, or just send it to a jump box or something like that. As long as you get it off the box, that's the key thing. Because again, we don't want to store our data with our backups right next door. We want them in separate spaces.
And I think I'll add to this too. I've also had tickets with customers where they're using Google Cloud and they're using Google Storage instead of S3. And I've seen some where it just works and some where it doesn't.
Yeah. I use Wasabi. It's like $5 for a terabyte, and I have probably 50 clusters that all use the same bucket, and I don't even think I've used enough to get out of their free plan. So it's so little storage that even if you just signed up for the free plan, you should be able to do it. And I like Wasabi. They're cool guys too.
All right, the next question is, how can I recover a cluster YAML file from a Rancher managed cluster?
Okay, one second. I have a script for that. Do I have that script here?
There's a PR on support. Yeah.
Yes. And I think this is just waiting for final approval. So I have a PR. Long story short, so we have, let me just go into, let's just do it the README. I'll share this in the links as well. So we store that RKE state file. Let me go ahead and just click on, no, whatever. We store the RKE state file as a config map in the cluster. Again, it was originally meant as like a safety maneuver. So what this script does is this goes in and gets this full cluster state, which is just a config map, and then basically parses through that using some jQuery and some set and replace. Mind you, there's a lot of them. And the idea is that it just outputs your cluster.yaml, at which point we can also get our RKE state file, and then you're ready to rock and roll at that point. I am working on a process for being able to extract an NCD backup locally. So you could take an NCD backup on and download it to your workstation and extract it without building a cluster. That's still in progress. I think I've got it worked out, but there's still some kinks I need to work out. So hopefully once that's done, I mean, you could really you could rebuild it anywhere at that point. And the idea there being is that I want to be able to give you the option to extract, like, hey, I just need this secret for this database credentials because some guy deleted it and I don't want to roll my whole cluster back. But that's still in progress.
That's good to know. So now here's another question about RKE.
Mhm.
If let's say that I have a cluster on 124 and I take a snapshot, can I restore it with a different version of the RKE binary?
Yes. Generally, we like it newer is better. So if let's say you took it with an older version of RKE and now you're restoring it, so let's say you're, I think we're on 126 right now, I think is what we're currently on. Let's say you backed it up on 1.1, and now you're restoring it in 1.2. That's generally fine. There might be some minor quirks, but that's generally fine. What I generally tell people is don't jump 2 versions. So going from 1.0 to 1.2 is fine. Don't go below 1 at that point, so you're not jumping 2 versions. Also, one of the things that I generally recommend, and I have a great class that I just did not too long ago on Kubernetes upgrades. I put it on here. Again, nobody ever got fired for taking too many backups. So one of the things that I do is when I'm upgrading my clusters, I take a pre-backup and a post-backup. So I take one that says, okay, this is my pre-Kates upgrade. I do my Kates upgrade, and usually it's also my RKE upgrade. And then once everything's done, everything looks cool, I take my post upgrade, and then I go to bed at that point. The idea being, if I need to if the app team comes in behind me and does something stupid, I don't have to undo my upgrade. I can just roll that back. But generally speaking, as long as you're staying in the 1.x line, you're usually very fine. If you're still in the O.x line, talk to us, and there might be some caveats with that. We've seen some issues with that.
Okay. Here's this might be going a little bit away, but can we talk about the difference between, an RKE snapshot restore process versus the new backup operator?
So the backup operator is really built just for the Rancher server, which is this right here. So a little bit of story time. Rancher, when we store everything as a Kubernetes object, so your downstream clusters, your projects, your node templates, all that jazz are just Kubernetes objects that we build in the local cluster. Well, how do you restore those? Well, you just take an NCD backup and you're done at that point. Well, how do you do that in Amazon? EKS doesn't give us an NCD restore. They don't give us that option. So we built the backup operator. It basically takes a YAML backup. It walks through all of our Rancher custom objects that we put in the Kubernetes and gets basically does a kubectl, get object minus o YAML, and actually I think it's JSON, and backs them up and then tars them up and sends them off. And then when you want to restore, it just does a kubectl apply and puts them back. That's really only for the local cluster and really only for Rancher objects.
Okay. I guess that feeds perfectly into this next question. So what do I do with an EKS cluster built with EKS control and then imported into Rancher?
So, and this counts for all imported clusters. Imported clusters, Rancher has no control under for the cluster. And what I mean by that is it can initiate a Kubernetes upgrade because it doesn't control it. EKS does. Now EKS is a little special, and Rancher can manage your EKS cluster for you. But if it's a traditional importer cluster where you built it outside of Amazon, and then simply you're just hooking it into Rancher so that Rancher could manage the deployments on top of it, there is no backup at that point as far as Rancher is concerned. You'll need to work with either Amazon, which I don't believe they have any option, or like a third-party tool like was it Valero, and then there's like Trilio or something like that. There is backup products out there that are designed to back up your Kubernetes cluster basically as a YAML backup, and do some more higher cool stuff. I believe they're paid products, so I haven't really tested them. That's kind of your option there.
All right, cool. Here's a interesting question. How about disaster recovery scenario between two different clusters? Is it possible to have an active cluster setup?
So clusters that span data centers, I've seen it work. I've seen, so I had one customer that they ran their NCD control plane and some other workers on-prem, and then they had workers up in Amazon. And they used direct links, so the latency was really good. That's great. The downside that happens there is what happens if on-prem goes down. Well, I still have my workers up there. My pods are still running. They're still serving traffic and everything's hunky-dory up there. But now I can't manage my cluster. And in this case, they were fine with that because really their Amazon was really more of their expansion area. So if they need to scale up quickly, they can scale up in Amazon and scale right back down. But the core of the app ran on-prem. Now, if you're, let's say, in Amazon and I want to have my cluster in West and my cluster in East, you can do it. Nothing in RKE and Rancher is going to stop you from doing it. The problem you're going to run into is latency. The latency is simply just too high between data centers, even in Amazon. And basically what's going to happen is your etcd nodes are constantly going to be crashing because they're going to be timing out between each other. And then, of course, you also run into the issue of how do you do quorum? If I have two data centers and I have three nodes, three etcd nodes in each one, and then I lose my link in between it, who's right, who's wrong? I don't know. Put your hands up and walk away. So you would really need to do 3 data centers, and it just gets really messy really quickly. I have seen customers, and we did a master's class on DR. The proper way to do this is to simply make your applications disaster recovery aware, such as one kind of the easiest approaches is in your CI/CD pipeline. Just deploy your app to both clusters, but set one cluster to scale to 0 and one to scale of whatever you need it to be, so that the secrets, everything are all matched up, and your DR plan is to simply scale up on my DR cluster and scale down on my production cluster. That's one option. We of course have a tool called Submariner. It's a Rancher product. It's of course open source that allows you to hook clusters together so that the clusters could talk to each other directly, so pods can see each other without having to open up ports and all that jazz. And that's really kind of more of a hybrid approach for doing things like database replication. And those are really cool things between clusters.
Okay. All right. We have 1, 2, 3, 4, 5, 6 questions left. So let's see. What are some best practices around pod sizing and setting resource limits for deployments and projects?
So what I do so I leverage, if you have a performance capacity planning team, let them do their job. They should be working with the application architects to give you those answers and say, I need this amount of memory, I need this amount of CPU. Small organizations just don't have that or just aren't in that maturity scale yet. At that point, what I do is I tend to set my limits a lot looser, and then leverage like Prometheus and say, okay, I'll deploy your app, and in 30 days, we're going to circle back around and we're going to look at your app. and you know, because at that point I have hard data. I say, hey, you asked for 2 gigs, you're only using a gig. I've only ever seen you spike up to 1.5 gigs, so I'm gonna set your limit at 1.5 gigs. Cool, cool, and just move forward at that point. You know, and really give. One of the nice things about especially monitoring V2 is we really made it really easy for app teams to see Grafana. So app teams can look at their performance and they can be the ones that decide, you know, hey, I need to up my memory, I need to lower my memory, I need to, you know, same thing as CPU memory. And then of course, the other one I love to use is Cube Cost, I think is what it's called. It basically lets you be able to report and say, this is how much money you're spending on my cluster. It's a great way. Suddenly when CPU costs money, everybody figures out a way to start saving CPU. So that's generally what I do.
Okay, cool. This is a completely random question, kind of on topic. What about dealing with expired certs that cause the Rancher server UI to become unavailable? How can we recover from that?
So that, and again, I have a script. Hold on. So, where is it here? It is in called the cluster agent tool. So what you would do is you go in, you would basically, let's say the SSL certificate's expired, you would go in and basically follow the Rancher install process to delete the old certs and reinsert the new certs to get the Rancher UI back up and running. And then once that's up and running, and I think we have a KV article on this as well, you'll run through this tool. This tool will basically go through your agents that have the old checksum. So Rancher uses a checksum of the certificate chain for the Rancher URL as a way to validate that, yes, I really am talking to my cluster. Well, if your certificate's expired and you've switched authorities, so let's say if you use DigiCert, as long as you redo for the same DigiCert, same root, same intermediate, just, you know, reapply the certificate and you're done. You know, give it 5 minutes and everything will just come back up. But if let's say if you switching from DigiCert to Let's Encrypt or something like that, then you would follow this process to go through and basically update your agents, and then they'll be aware of the new certificate at that point, and you're back up and rolling at that point.
Okay. All right. What are your views on Kubernetes cluster level DR using sync replication at storage level? And what are the pros and cons of this approach?
So in a previous life, I was a storage administrator, and we had Pure Storage, and we were using Pure Storage replication. And basically, I had my Kubernetes cluster living in production in a VMware farm, sitting on top of a Pure data store. And then I was using storage-based replication under the covers, and then using what's the VMware? It's Site Recovery Manager in VMware to recover my VMs. Now, one of the key things is I put all of my NCD nodes on the same data store, so that I knew that, hey, all 3 of these VMs should be in lockstep with each other. You know, as close as I can get it. I know Pure doesn't do it does do synchronous writes. So I know that, you know, hey, if the VM said write this down to disk, it made it down to disk. And generally it just came up at that point. And of course followed the same restore procedure. I will note that does not replace having good backups. So make sure that you still have backups. You still have them preferably stored in S3. It can get a little complicated if you're doing like bubble DR testing where boxes can't reach out to the internet and stuff like that. In that case, we might have to get a little creative with that. But I have done it, and it has been successful.
Okay. Now, what about moving nodes between RKE clusters?
Yep, totally doable. I do it all the time in my lab. The key thing to remember is when you when you remove a node, RKE is going to go through and remove it from the cluster. It's going to tell Kubernetes, hey, you get rid of this node. But one of the key things is it's not going to clean itself all the way up. So we have this script called the extended cleanup rancher script. This script is designed to nuke a node. It deletes every single thing on this node that has to do with rancher, has to do with Kubernetes, and really Docker. It just gets rid of everything. Please be careful. This script will delete a production box if you tell it to delete a production box, even if it's currently in use. As you can see here, it quite literally just will delete every VM on the every container on the node, every volume, certificates, everything. So if let's say I'm moving a node from one cluster to the other, I go in. If it's in a rancher managed cluster, I just delete the node and let rancher do its thing. Run the cleanup script. I then bring it in as a fresh node on the other side, and it's back up and running. What I would not do is skip the cleanup step or skip the delete step. If you just pull the node out of one cluster and stuck in another cluster, you're going to be having every problem to Sunday. It's not going to be good.
Okay. Now, what about transferring a downstream cluster between rancher instances?
So I think we have a KB article on that. So we do that. We actually do it for hosted brancher. So hosted brancher, if you want to, we can absorb existing clusters, and we basically leverage the backup operator to go and grab all those Kubernetes objects that we need for that cluster, and then we inject it into the other one. I'll have to find it somewhere. We have a KB article, so if you go to support.rancher.com, and I believe it's searching for, it's like hosted rancher, like migration or something like that. It walks you through the steps on how to do it. But it is doable. There's just some work that needs to be done in order to make it happen, but it's definitely doable.
Okay, cool. And I just had a request to share the link for any resources for KAS disaster recovery.
Yep. So that would be this would be this link, and I'll just paste that in Slack so you can respond with that.
Cool. All right, now last question. What about, hold on. What kind of DR options do you propose for stateful workload resiliency?
I guess, are you more looking at like databases and doing DR for databases? Or, yeah, because yeah.
Not sure.
Yeah,
I would assume so. Database, Kafka, things like that.
Yeah. So let's assume that they're talking about databases. Please correct me if I'm wrong in the
Or
chat.
he said in-memory cache.
Oh, yeah, it would be more of you need to work on, you need to, your application needs to be providing the availability. So perfect example, and I believe I covered this in my databases master class, where I go over, I'm a big fan of our product Submariner. Basically creates an IPsec tunnel between clusters. So doing something like spinning up a 3-node RandaDB Galera cluster and do it on both sides. And then I do my traditional master application, and I just start log shipping between the two. I would do it as if these were just regular old VMs in my environment. And because Submariner, DNS works between the two, and I can directly talk, pod-to-pod communication just works at that point. So all that kind of jazz, it just becomes like a regular old VM farm at that point. Anything more than that, then you would need to start opening up node ports to be able to do log shipping between the two, or application-based replication. I believe Memcache has that, and I believe that there is a Helm chart out there. So I would kind of maybe, if you're more looking at like Memcache, I would kind of start walking down that route first.
Okay. All right, good to know. I think that's all the questions.
Okay, cool. Awesome. Of course, I will post the slides in the GitHub link, and then I believe Connie will also send them out in the email as well, along with the video. And of course, as always, we have the Slack channel. I try to stay in that Slack channel for the next couple of days. So if you, as soon as we get into this call, if you have a question, please feel free to pop it in that Slack channel. We'll be more than happy to help you out.
Thanks, Matt. Yes, that's correct. We will share the slides and also a link to the recording in a follow-up email, which should be going out in the next few days. So, yep, and we'll also include the link to your GitHub repo for those who were not able to access it today. And just a few final details to wrap up today. Matt, did you have anything else to share from your slides? Just want to make sure before I
Nope, you're good to take over.
Transition. All right, cool. So just a reminder, you can check out all of our products and projects, all open source on rancher.com. We've added a few logos actually, since there are a few missing from this slide. So head over to our website to check them out. And a few upcoming events. If you haven't heard about SUSECON yet, you can visit SUSECON.com to learn a little bit more. It is taking place next Tuesday through Thursday, May 18th to 20th. Lots of great Kubernetes content on there, along with edge-focused and Linux-focused. So check out the agenda and register for free at SUSECON.com. And our next masterclass will be Tuesday, June 1st. So we do have a few weeks before our next class. Feel free to sign up. Also, again, on rancher.com/events, you can find more info about installing RKE2 on an air-gapped network. And last but not least, a reminder, we do have some more basic training courses and also a more advanced certification program. If you want to get certified to become a Rancher operator, you can do so at academy.rancher.com. And that's all for today's masterclass. Thank you again, everybody, for attending. Thank you, Matt and Lucas, for a great presentation. And we will see everybody very soon. Have a great day.